Donc, bienvenue à cette seconde journée de l'édition 2021 des conférences Hugues Leblanc au département de philosophie de l'UQAM. Mon nom est Christophe Malaterre et je suis professeur de philosophie des sciences ici à Montréal. Welcome to this second day of the 2021 Hugues Leblanc lectures at the philosophy department of UQAM. I'm Christophe Malaterre and I'm professor of philosophy of science here in Montreal. Comme je l'ai dit déjà hier, et puis je vais le redire encore aujourd'hui, c'est toujours un honneur et un véritable privilège que d'accueillir cette année Elliott. Elliott est professeur au département de philosophie de l'Université du Wisconsin à Madison. Il est titulaire des chaires William Willis et Hans Reichenbach. Et je pense que comme chacun le sait, certainement sa recherche s'inscrit dans les domaines de la philosophie des sciences et de la philosophie de la biologie d'évolution. As I said yesterday, and I'm going to say it again today, it's always a real honor and a privilege to have with us this year Elliott. Elliott is William Willis Research Professor and Hans Reichenbach Professor in the Philosophy Department at the University of Wisconsin-Madison. And as everyone knows or should know, his areas of research are in the philosophy of science and the philosophy of evolutionary biology. Alors bon, le reste de la conférence est en anglais. Je vais basculer vers l'anglais. I'm going to speak in English only from now on. For those of us who were not with us yesterday's lecture was on parsimony and Occam's razor, and tomorrow's lecture, because it's a set of 3 lectures. Tomorrow's lecture will be on values in science. And so today's is going to be on scientific realism. Just one thing though, since the lectures are on Zoom, I'm going to repeat a few things I said yesterday and that I hope should make everything run smoothly on Zoom. So during the talks, please mute your microphone. During the Q&A session, then if you want to ask a question, open the chat. It's Conférencier in French, and simply write an H, type H for hand in the chat. And then I'll monitor the questions, and when it is your turn to ask a question, then please unmute and make sure your video is enabled. I'll repeat also, please be respectful at all times and note that the lectures are recorded. All right, today's lecture is entitled Realism, Empiricism, and Instrumentalism. It will run for about 50 minutes and will then be followed by a commentary that I will do today. And we'll then have a brief reply by Elliott, and we will open the floor for questions. Right, I think that's all I needed to say right now. So we should all be set. So now join me in welcoming Elliott for this second lecture of the 2021 Leblanc lectures. Elliott.
Okay. Okay. So my second lecture is on realism, empiricism, and instrumentalism. As I mentioned in the first lecture, I'm going to start with an idea about probability and then put it to work in what follows. Some of this will be material you've already heard me say, but I'll remind you of it. Just a minute. I'm having trouble getting this slides to advance. How strange. Christophe, I'm having a problem here. I can't get the slides to move around. I don't know why that is.
If you have your mouse over the lower left corner, would this trigger some arrows that would appear on the screen?
On the lower right corner, I have arrows here.
Or you have arrows?
on the left, on the right corner
And
here. Oh, here it goes. Now it worked.
Okay.
Yay. I just wasn't in the right place. Okay. Try again. Okay. So I talked about the law of likelihood last time, and I urged you to never in the rest of your life confuse the probability of H given O with the probability of O given H. And I mentioned Gremlins as a device for remembering that important distinction. And I'm going to make a new point about the law of likelihood and the difference between the likelihood ratios here and the posterior probability ratios here. I told you before, without explaining why this is true, that this equation is a consequence of Bayes' theorem, that this ratio has to equal that ratio times that ratio. And here's the simple point I want to make about this. You cannot deduce that this is bigger than that simply from the fact that this is bigger than that. And you can see that since this is a product, this quantity is a product of these two things, you can't just focus on this and think that you can go from that being bigger than one to this thing's being bigger than one. And the name for the mistake, the fallacy of concluding that H1 is more probable than H2, given the observations, from the fact that H1 has a higher likelihood than H2, given the observations, that's called the fallacy of base rate neglect. So we're not going to do that, but it's going to come up in a bit. Okay, so here's a roadmap of the topics that I'll be talking about. I'll explain what realism and the alternatives are. And then I'm going to talk about this very influential argument that's called the no miracles argument for scientific realism. And then I'm going to talk about two arguments, one against realism and the other in favor of realism, that appeal to what I'm calling a track record. Namely, if we look at the history of science, what has happened? And we can take a lesson from that history as a way of evaluating what realists say about science and what anti-realists say. And then finally, I'll talk about this very central idea that realists say that the distinction between observable and unobservable that anti-realists typically think is important is not, as realists say, epistemically significant. I'll explain what that means. Finally, I'll talk about instrumentalism and then a distinction between monism and pluralism. Here's a hint at what I'll be doing. The first half of the lecture will be very negative. I'll be reviewing three arguments, one of them in favor of realism, one of them against realism, and a second one also in favor of realism. And I'm going to be saying for different reasons these arguments fail. But then I think this point that realists have traditionally made down here, I think is a very good argument. I'll explain why. Okay, so that's my roadmap. Okay, there's an older vocabulary that I'm sure you're familiar with in philosophy for using the terms realism and empiricism. In this tradition, realism is opposed to idealism. It's the idea that there's a physical world that exists independently of the mind. Realists say yes, idealists say no. And likewise, there's a familiar sense from the history of philosophy of the difference between empiricism and rationalism. And the question there is whether all knowledge comes from sense experience. Let's forget that familiar traditional usage of the terms and talk about these usages here, which are standard in philosophy of science. Scientific realism is the view that science can give us justified beliefs, even knowledge, about unobservable entities. And anti-realism denies that science can give us such knowledge. There are three varieties of anti-realism that I'll be distinguishing. Empiricists say that we should be agnostic about propositions concerning unobservable entities. Fictionalists say that claims about unobservables are always false. They're fictions, they're not true. And finally, instrumentalists, at least old-fashioned instrumentalists, have said that claims about unobservables are neither true nor false. Okay, here's a little history. Possibly this is where the modern issue about realism and anti-realism got started. Maybe there were predecessors, I'm not sure, concerning the realism debate. So as we discussed yesterday, thanks to Molly's interesting comments on my lecture then, there was some discussion of geocentric astronomy and Copernican astronomy. Molly and I discussed that in connection with the principle of parsimony. I want to draw your attention to an aspect of this controversy a bit later than Copernicus, Galileo's defense of heliocentrism, something I'm sure you're familiar with. In 1610, Galileo used the observations he had made with the new telescope to defend heliocentrism. And he met with opposition within the Catholic Church. And in 1616, the Inquisition declared heliocentrism to be formally heretical. Heliocentric books were banned, and Galileo was ordered to refrain from holding, teaching, or defending heliocentric ideas. Some years later, Galileo published the Dialogues, which implicitly defended heliocentrism. And the Inquisition put Galileo on trial and found him vehemently suspected of heresy, sentencing him to indefinite imprisonment. And Galileo was under house arrest until he died. Now, the church did not object to Galileo's using the hypothesis of heliocentrism to make predictions about the observed motions of the planets and the sun. What they objected to was his saying that heliocentrism is true. So Galileo was a realist about heliocentrism, and perhaps the Inquisition would have left him alone had he been an anti-realist. So there is an interesting historical beginning of this ongoing debate within philosophy of science. So realism, as I'll use the term, this is pretty standard, says that the goal of science is to find theories that are true. And one question one might raise at the outset is whether this is a sociological claim, a claim about what scientists want. And if it is, maybe we could discover whether realism is true just by doing a poll and asking scientists, what are you trying to do when you're looking for a theory? I don't think that's the right way to look at the realism debate. It's not a sociological question at all. It's a question first about what science can achieve, regardless of whatever scientists think it can achieve. And also, we want to know what the goals of science ought to be. That's a normative question, not settled by polling scientists about what they're trying to do in their careers. There are two versions of scientific realism that are in the air and have been for a long time. Some realists restrict their realism to a claim about the attainable goals of science. And the claim that current scientific theories are true isn't part of what they mean by realism. It's a goal. No one's saying that we've achieved that goal as of the year 2021. On the other hand, there are many realists who are realists about current theories. They say, for example, that the theory of evolution and the theory of general relativity are true in what they say about both observable and unobservable entities. Now I turn to the first of several arguments that I'm going to seek to debunk. It's, I think, the most influential argument for realism, and it concerns the first kind of realism, realism about a single theory. It's due to Hilary Putnam, who's famous for this slogan that realism is the only philosophy of science that doesn't make the success of science a miracle. What's the argument he's using? In making this argument, realists are using a form of inference that they call inference to the best explanation. They say, so consider a theory that's been very predictably successful, and we want to know what the best explanation would be for the fact that the theory has predicted observations very accurately. And realists often say that if the theory were true, that would explain the theory's past predictive success. But if T were false, the theory were false, the success it had in predicting accurately would be a miracle. And this is called now the no miracle argument for scientific realism. It's an argument that's made about a particular theory that has been predictably successful so far. And I'm hoping that this no miracle argument for scientific realism reminds you of an argument from yesterday, the one about the example that concerned student plagiarism. So I observed that two of the students in my class submit essays that are extremely similar to each other. And I consider two hypotheses about their work. The first says it's a common ancestry hypothesis. It says the students went to the internet and chose a paper from which they both copy. And the separate ancestry hypothesis says the students work separately and independently. And we might say of this what realists say of predictively successful theories, namely, if the common ancestry hypothesis were true, that would explain the observation. But if the separate ancestry hypothesis were true, the observation would be almost a miracle. And here I want to use the law of likelihood to talk about, as a way of understanding what explaining and failing to explain mean here, what a miracle or a non-miracle means here. So how could the no miracles argument for scientific realism be formulated as a likelihood argument? Well, here are the two hypotheses. The theory is true or the theory is false. And what we observe is the theory has been very predictably accurate. So here's the argument, the no miracles argument formulated as a likelihood argument. O is true, the probability of O given H1 is far greater than the probability of O given H2. Therefore, O strongly favors a realist interpretation of theory T. That's the realist interpretation of theory T. Sounds pretty good. Can we change the conclusion of this argument by inserting the word probably? Can we conclude that since H1 has a higher likelihood than H2, that T has a high probability, that H1 has a high probability of being true? And the answer is no. That is a fallacy. It's the fallacy of base rate neglect. You can't get there from here, from the fact that T is true has a higher likelihood than T is not true. You can't conclude that T has a higher probability of being true than not T. So here, how do we understand the no miracles argument for scientific realism, which is couched in the language of inference to the best explanation? If you formulate it as in this way, it's a fallacy. It commits the fallacy of base rate neglect. I prefer to understand the no miracles argument as a likelihood formulation, and it looks pretty good. The evidence strongly favors the hypothesis that the theory is true over the hypothesis that the theory is false. And Putnam and other realists have taken that to be a way of saying that scientific realism is the confirmable hypothesis when it's made about a particular theory. Being a realist about a theory is the favored interpretation of the theory given its predictive success. So I think the likelihood argument for the realist interpretation of this theory, the interpretation that says the theory is true in what it says, looks pretty good, but I think there's a problem in the argument. The likelihood argument I just described compared H1 and H2. H1 is what the realist wants to say about this theory, but H2 is not what empiricism says about the theory. It doesn't assert H2. Rather, the empiricist interpretation of the theory says that the theory is empirically adequate. So if we want to compare the realist interpretation of the theory with the empiricist interpretation of the theory, we should compare these two likelihoods. But here we run into a problem because those two probabilities are equal. The probability that the observation that this observation statement is true is just the same whether T is true or you say that T is empirically adequate. So the observation, even if it favors H1 over H2, does not favor the realist interpretation of the theory over the empiricist interpretation of that same theory. So the no miracles argument is not a good argument that tells you why realism about a theory is superior to empiricism about that same theory. Okay, I'm now going to go to a different argument, which is an argument against realism. What I just told you was the no miracles argument is an argument for realism, and it fails. Now I'm going to look at an argument that anti-realists have made to criticize realism. It's called the pessimistic induction argument. So it's a track record argument. As I mentioned, it looks at the history of science and claims this is true about the theory. So we see there are numerous theories in the history of science fit the available data for a long time, and then new observations were obtained that refuted those previously successful theories. And it's an inductive argument. So from this sample that we draw from the past history of science, we are supposed to conclude that with high probability, that's what the double lines mean here, the present theories we have, which fit our present data, will probably turn out to be false once new observations are obtained. It's an inductive argument, and it's pessimistic. It says, sure, the theories we now have look great, but we should learn a lesson from the history of science. The lesson being that they're probably going to turn out to be refuted by new observations tomorrow or next year or soon thereafter. Let me try to describe this pessimistic induction argument in the form of an urn argument. It's an argument, the sort of example that people talk about probability, like you have an urn, it's filled with different balls. In this case, the urn is filled with different balls, and on each ball, some theory is written down. And suppose we've sampled from this urn numerous times, and we look at the history of that sampling process. That's what the history of science is supposed to be like according to this urn model. And we found that we've got 99% of the theories that we've pulled out of the urn have turned out to be false. By making observations, we've determined this. And so we're supposed to conclude from this urn model that tomorrow, when we come back to the urn and draw some new balls from it, the same thing is going to be true. We should expect that 99% of them are going to turn out to be false also. So I think if you understand the pessimistic induction argument as this kind of urn model, it makes a lot of sense. Because if this urn had 99% green ball, this ball had, suppose we sampled a lot from this urn and we found that 99% of the balls were green. That's a good reason to think when we come back tomorrow and sample from the same urn, the probability is 0.99 that the balls we sample then are going to be green too. Pretty good inductive argument. It's a sampling from an urn argument. And the simple point about this urn model is that when you sample from the urn, it doesn't change the composition of the urn. The urn is the same all the way through. If you like, think of it as sampling with replacement. If you take a ball out, you look at it, and then you put it back in the urn. But the composition of the urn remains the same. Here's a different urn model that you might use to represent the history of science. The urn starts off with some unknown mixture of theories. We draw a theory at random from the urn and examine how strong it is by using observations to test the theory. Then we replace the theories in the urn so that all the theories that are in the urn now are at least as strong as the one previously drawn. So we change the composition of the urn each time by updating the theories that are in the urn, making sure that each of them is consistent with the old observations. The composition of the urn does not remain fixed, it's revised at each round. Now consider this argument about this new kind of urn model. The average theory drawn so far has been false. Therefore, all future theories will also be false. I don't think that follows at all, because we're improving the composition of the urn each time by updating. We're getting rid of the ones that are no better than the one we just refuted. We're getting rid of all the theories that used to be in the urn that turn out to be incompatible with the observations we've made. This is a different kind of earned model, and it doesn't lead to a pessimistic induction argument of the sort that anti-realists have wanted to make. This inference is a mistake. And this earned model is, of course, extremely idealized, but I think it's a better idealization than the earned model that anti-realists are using in their pessimistic induction argument. What's wrong with the anti-realist pessimistic induction is it assumes that the frequency of accepted theories that are false will never change as science moves forward in time. We're always sampling from the same urn. The track record will always be the same, but maybe things are improved as we replace candidate theories with better candidates. Now, realists, of course, reject this pessimistic inductive argument. I don't think they necessarily will use my urn argument for what's wrong with the pessimistic induction argument, but realists say, no, 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 that's wrong. What they often do say is, we have an optimistic induction argument in which we're not just looking at any old theory that we draw from an urn. We're going to look at theories that have succeeded in making novel predictions, which have turned out to be correct. That's a special class of theories that have been extremely effective. And the optimistic induction says most past theories that made successful novel predictions have turned out to be approximately true. Therefore, probably our present theories that have made successful novel predictions are going to turn out to be approximately true as well. So this is the optimistic induction argument that realists offer as a substitute for this attack on realism that anti-realists have made in their pessimistic inductive argument. Sometimes this argument has been criticized, the realist optimistic induction argument has been criticized by pointing out counterexamples. And a standard counterexample is the wave theory of light, which made novel predictions successfully in the 19th century, and it turned out not to be approximately true, we now believe. To me, that's not an argument against the optimistic induction argument. The argument doesn't say that all present theories that have made successful novel predictions are true, or all past ones are true. It says most in the past have been true. And this one example doesn't show you, I think, what's wrong with this probability argument that I've got up here. But I think there are better objections to the realist optimistic induction argument. The first objection has to do with the way the argument uses the concept of approximate truth. So I think the idea that a theory is approximately true makes sense for a very special kind of theory. Consider these three statements about Sue's height. I think we can talk about how close to the truth P1 and P2 is. P2 is closer to the truth than P1. And so P2 has a higher degree of approximate truth than P1. That seems fine to me. And the reason it seems to me unobjectionable is the true statement we're talking about is a statement about a quantitative property of an individual. We consider this problem. Suppose the truth about light is that it's neither a wave nor a particle. And I ask you, how approximately true is the statement that light is a particle and the statement that light is a wave? To me, it's completely unclear how you're supposed to understand the idea of approximate truth. These are both false. Which of them is closer to the truth? I don't know. So that's my first objection to the optimistic induction argument that realists make. It's using the idea of approximate truth in a way that I think often does not make sense. The other thing, perhaps a clearer objection, is I think the premise of this argument is question begging. Notice that the premise of the argument is that most past theories that have made successful novel predictions have turned out to be approximately true. Well, I think an anti-realist will say, what makes you think that's correct? I mean, what's unobjectionable is that these theories so far have not been refuted by observation. We grant that. But since when is that the same as showing that the theories are approximately true? And so they'll express skepticism about that. And I think they're right to do so, because the argument is question begging. Okay, so those are the three negative things that I've said so far. I've talked about the realist no miracle argument, and I suggested to you that it does not show why a realist interpretation of the theory is better than an empiricist interpretation of the theory. I then talked about the anti-realist pessimistic induction, and I talked about it involving a dubious sampling assumption. And finally, I just talked about the realist optimistic induction and suggested that that argument begs the question. So let me try to be more positive in my outlook on life and talk about an argument that I think is actually a good argument that realists have made against empiricism. Realists focus on the way empiricists use the idea of observability. Empiricism says that science should never conclude that a theory about unobservables is true. The most that science can ever do is find theories that are true in what they say about observables. Did I say that right? Scientists should never say that a theory is true in what it says about unobservables. The most it can say is that what it says about observables is true. And that's what the word empirically adequate means, that the theory is true in what it says about observable entities. And that's what empiricists say. Von Frossen is the person I'm thinking about here. Realists criticize this empiricist thesis by saying, what does the distinction between observable and unobservable mean? We got to get clear on that. And then they say, or they ask, does this distinction have epistemological significance? And I want to say what that means. Here are some choices. I hope you'll get the feeling for what's intended here. The distinction would be epistemologically significant if propositions about unobservables were always unknowable, whereas propositions about observables were sometimes knowable. That would make the distinction epistemologically significant. But here's another alternative. It would be the distinction would be epistemologically significant. Whoops. I seem to have jumped way ahead. Why am I seem to be going in the opposite direction now than I was going in before. Okay, sorry. Okay, here we are. It could mean the first thing about knowability. It could mean maybe propositions about unobservables are always less probable than propositions about observables. Or it could mean that propositions about unobservables are always more weakly evidenced than propositions about observables. Any of these would be a possible way to say, look, the difference between observable and unobservable entities matters epistemologically, because look at what happens when you think about knowledge or probability or evidence. Okay, what does the distinction mean? Well, observable and unobservable are properties of entities. For example, the computer you're now looking at is an observable object, whereas an electron in a cloud chamber is not an observable thing, though realists say that, of course, that it's detectable. Empiricists say that an object is observable by human beings precisely when human beings would be able to perceive it without instrumentation if the circumstances were right. So here's a question. Are dinosaurs observable? And empiricists say they are, because if we and they were in the same place at the same time, we would see them. Whereas electrons are not observable, since even if we and they were in the same place at the same time, we couldn't see them without instrumentation. We couldn't see them at all. So according to this usage that empiricists buy into, objects can be observable even when they are too far away in space and time for us to see them, but objects that are too small for us to see are unobservable in their use of that terminology. So here's, if we understand the idea of observable and unobservable in the way I just described, we can ask the question, does the fact that dinosaurs are observable while electrons are not show that science can find true theories about dinosaurs, but cannot find true theories about electrons? And I agree with realists who say that no, it doesn't mean any such things. And the point that I think ought to be made here is that dinosaurs, though they're observable, and electrons, though they're unobservable, have something very important in common with each other. Dinosaurs are observable in the sense defined, but we never actually observe them. And we never actually observe electrons either. So the evidence we actually have for both the existence of dinosaurs and the existence of electrons is similar in that neither involves direct observation. And this suggests that we may be able to assemble strong evidence for the existence of both dinosaurs and electrons. So here's a way of fleshing out that idea using our friend the law of likelihood. I have two propositions about dinosaurs and an observation. Sorry, wrong. Three propositions about dinosaurs, 3 propositions about electrons. Dinosaurs once roamed the earth versus dinosaurs never existed. We have lots of observations that tell us that strongly favor P1 over P2. We have observations that tell us that P1 has a much higher likelihood than P2 in the sense of the law of likelihood. But when you think of comparing P1 to P3, the problem suddenly changes. There's no observation that discriminates between P1 and P3. I think the same thing is true about the Q propositions. We have plenty of observations that favor Q1 over Q2, but no observations could discriminate between Q1 and Q3. And the terminology that philosophers of science like to use about P1 and P3, and also about Q1 and Q3, is that these are empirically equivalent theories. It's not just that they agree concerning the observations we have today, they agree about all possible observations. Observations can't discriminate between P1 and P3. They also can't discriminate between empirically equivalent Q1 and Q3. So these similarities between the P's and the Q's hold, I think, despite the fact that P1 is about an observable thing, namely dinosaurs, while Q1 is about an unobservable thing, namely electrons. So this is what I think is a very good argument against empiricism. Empiricists hold that we're cut off from having justified beliefs about unobservable entities, but that we're able to have justified beliefs about observables. And I think the right reply to this is that, in fact, there are soluble and insoluble discrimination problems pertaining to P1, just as there are soluble and insoluble discrimination problems pertaining to Q1. So P1 and Q1, I think, are in the same boat epistemologically, despite the fact that P1 is about an observable entity and Q1 is about an unobservable. Okay, so where are we? The no miracle argument for realism failed. The pessimistic induction against realism failed. The optimistic induction for realism failed, so I claim. But here's some good news. The law of likelihood, I think, shows that we're not cut off from evaluating theories about unobservable entities. we sometimes have strong evidence favoring some theories about unobservables over others. And this is an argument for realism and against empiricism, who claim that we are cut off from having justified belief or knowledge or evidence favoring theories that are about unobservable entities. Okay, so the lecture was called Realism, Empiricism, and Instrumentalism. And so far I said hardly anything about instrumentalism. I've given you the one argument I think that is conclusive about realism and empiricism. I think of the two of them, realism wins. But now I want to compare realism to instrumentalism. As I mentioned briefly, instrumentalism used to be formulated by saying that theories are instruments, they're tools, and they don't have truth values. They're neither true nor false, any more than a hammer is true or false. That's a category mistake to say that a theory could be true. I think that's a mistake. No one says that anymore. I think what instrumentalism should be formulated in this newer way is to say, look, sure, theories have truth values, but the goal of inference in science is not to find theories that are true. The goal is to find models that will be predictably accurate. And as I hinted at last time when I talked about AIC, the Aki-Ike information criterion, this is a very important idea when the theories under test are models that contain idealizations, since idealizations are false. Nobody wants to be a realist about such models. And as I mentioned last time in connection with the models null and diff about the two fields of corn, when you test models that you know contain idealizations, what are you doing? What, are you trying to find out if they're true? No, you already know that they're false. What you want to know is whether these false models will make accurate predictions. And the AIC provides a possible way of evaluating models for their predictive accuracy, even when they're known to be false, as the null model from yesterday was known to be false. And you take into account how well the model fits the data at hand and the complexity of the model as measured by the number of adjustable parameters. And here are the two models I was talking about. And depending upon the data, AIC may judge that null will be more predictably accurate than diff, or it might reach the opposite conclusion, again, depending upon the data. So I think there's a lot of room in science for this enterprise in which we're testing models that all contain idealizations. We're not interested in testing them for whether they're true. We're trying to figure out if they're going to make accurate predictions tomorrow. So instrumentalism, as I would understand, it says the goal of science is to find theories that are predictively accurate. And I put predictive accuracy in a different color from red for true. Realists and empiricists disagree a lot about a lot of things, but they think finding true statements is what science is all about. And here I want to mark out a difference between instrumentalism on the one hand and realism and empiricism on the other. So realism and empiricism are different. Sorry, instrumentalism and empiricism are not the same. Which is better in this last competition that I want to describe? Well, here's a general comment about the way realism, instrumentalism, and empiricism have been formulated typically in recent philosophy of science. They're usually formulated as monistic doctrines in philosophy. They say that there's one goal that all scientific reasoning has, to find true theories or find theories that are empirically adequate or find theories that make accurate predictions. And I want to suggest that it's worth thinking about a pluralistic alternative to these monistic theories. Maybe some scientific research aims to find true theories, whereas other research aims to find idealized models that will make accurate predictions. If so, there's no such thing as the one and only goal that all scientific research has. So let me summarize some of the main points that I've made today. Empiricists think that the distinction between knowable and unknowable entities coincides with the distinction between observable, knowable, and unknowable, coincides with the distinction between observable and unobservable. And I tried to cast doubt on that. There's an argument for empiricism called the pessimistic inductive argument that I think is a failure. I think there's good reason to think that science is not cut off from finding good theories that are about unobservable entities, and the law of likelihood is relevant to understanding how that's possible. And finally, I suggest that we should be pluralist about the goals of science. There's room for both realism and empiricism in our picture of how science works. So thanks.
Thank you so much. So this is when we all clap virtually again. Thank you so much, Elliott, for this lecture. I'm going to move on to the commentary straight away. We've had realism is such a complex issue and such a also long-lasting issue in philosophy of science. So it's really good to have a lecture such as yours that disentangles some of the key arguments on realism. So let's see if I can share my screens now.
I should take mine down, correct?
I think, yes, you do. Let me see. Okay, so here we are. All right, I guess you can see the first page. So I'm going to elaborate on some of the ideas we've just heard about, and just very simply propose some possible directions among many for additional discussions and questions. And I'm sure there will be many. What's really somehow puzzling that this debate on realism is probably one of the most tenacious, durable, complex, intricate debate that has ever taken place in philosophy or in philosophy of science. And yet at the same time, it can appear as somehow a fairly, strange debate. And this is probably so because it arises as the result of a tension somehow between maybe what we can call like conflicting intuitions that we have about science. On the one hand, it seems that we all agree that what science tries to do is to describe, to maybe understand or predict the world, which is our world that we know pretty well. And unless science has erred a lot, this is a world that is made up of quarks and atoms and molecules and beavers and then they build dams and planets and suns and all this stuff. And these things have been around for a long time. It has been so, for instance, for 1,000 years ago. And this is the world we live in. It seems to be really, really real somehow. And this is the world that science describes. So yes, we should all be realists. What's the point about it? And at the same time, we also have this intuition that the concepts that are built by science, they're the product of historically situated debates, observation, experiments among scientists. So true, the term electron didn't mean the same thing 1,000 years ago compared to what it does today, if it meant anything. And so the thing is, how can we say that the world, as understood 1,000 years ago, included electrons, if it did? And so it would seem that the existence of electrons depend on our conceptualization of the world, and therefore somehow that if today we think that the world includes electrons, maybe in 1,000 years the world will no longer include electrons because we will potentially have found something else. Science will have found something else. So there are these conflicting intuitions that we have, So one part of me wants to be a realist intuitively, and another part, when I'm told about the history of science, wants to be somehow cautious about being a realist. And this may be the where we find the roots of the a lot of the debates on realism versus anti-realism. So roughly, we can say that realism is an epistemic attitude that recommends belief as true or approximately true, depending in aspects of the world as described by science. And then how should we think about anti-realism? So already there's potentially a lot of discussion about even this definition of realism, but even just simply based on this definition, how should we think about anti-realism? Then it can be maybe even two things. It can be simply an epistemic attitude not recommending such belief, and then that leaves open which attitudes to have concerning scientific statements. Or it could be an epistemic attitude recommending a specific something attitude with regards to aspects of the world as described by science, with this something possibly being, not to believe as true, agnosticism or acceptability or something else, depending. So one can understand that there can be many types of realists and many types of anti-realists as well. So the realist position that Elliott sketched here, we had argument that favored scientific realism against constructive empiricism, the empiricism of Van Fraassen typically, and which also is a realist position that is somehow more ecumenical towards instrumentalism, the way I understood it. And the strategy that Elliott took was to revisit known arguments about realism, especially in the light of probability inferences and the law of likelihood. So we revisited the numerical argument, which is typically an argument in favor of realism, and Elliott showed that, with his arguments, that it fails also. The pessimistic induction argument, which is an argument against realism, it fails. The optimistic induction argument in favor of realism fails. And then we also revisited the distinction between observable and unobservable as being not epistemically significant, and this is an argument then against empiricism, and the argument was that this point succeeds. And Elliott ended with a hint at a pluralistic position. So what I'd like to do is offer just 3 lines of possible discussions or three different points here. The first one is to try to revisit a bit the fourth argument, which was an argument about the distinction between observable and unobservable as not being epistemically significant. I think there could be a debate about whether dinosaurs really qualify as observables, but here I'd like to just focus on the fact that this was taken as an argument against empiricism, and because this distinction is not epistemically significant, then empiricism is wrong. And empiricism was characterized by Elliott by statements such as, and here are quotes, some statements on the slides. Science should never conclude that a theory about unobservables is true. The most that science can do is find theories that are empirically adequate. And another quote says, we should be agnostic about claims about unobservables. So this is how empiricism is viewed. So here I'm going to just play a little bit the devil's advocate for just the sake of the argument here, and quote. I've got 2 quotes from Bas van Fraassen here. So he says in his Saving Phenomena in his 1976 paper, anti-realism is a position according to which the aims of science can well be served without giving a literally true story, and acceptance of a theory may probably involve something less than belief that it is true. And then in another paper, he says, I do not advocate agnosticism about the unobservable, but claim that belief is supererogatory as far as science is concerned. You may, if you like, but there is no need. So maybe here there is some ways, I don't know, to refine maybe the divide between realism and constructive empiricism. It seems to be a bit that maybe not totally that at odds with each other, but I don't know. It would seem that from the quotes, Van Frassen's quotes, so that a constructive empiricist, for a constructive empiricist, what really matters is theory acceptance. And that empirical adequacy is all that is really needed for accepting a theory. As a consequence, belief in the truth of a theory is not needed for accepting a theory. But conversely, if we understand what the quotes that you just showed, it would seem that belief in the truth of a theory is not forbidden for a constructive empiricist. So my question would be, what is really at stake between realism and constructive empiricism? Is it really the notion of observable and unobservable, or is it something more profound? Is it something about the notion of theory acceptance that maybe is not really capturing the shared aim of science? Or is it about the foundational notion of empirical adequacy that might be on the basis of observables that would be then inappropriate a criterion for theory acceptance? Now, a second comment I would like to make is about the notion of truth. Realism is about believing as true or approximated true as that some aspect of the world as described by science. Truth appears to some, and may potentially made it to be a delineation that is too sharp, too strong. It's dichotomous. And this shows in the fact that different realists have made different proposals for a notion of approximate truth. So we've seen that it's some cases it's a difficult notion to make sense of, like in the the wave particle theory. But there have been different proposals on the table. For instance, Popper's verisimilitude, possible worlds approach, type hierarchies approach, limiting cases approach. So my questions would be, are any of these views more promising than the others, or should we just say, no, there is nothing in approximate truth that is worth pursuing? And in this case, the question I would have is, why is it so? Is it because no approximate truth notion that would make sense is possible, or is it also maybe because going the route of approximate truth would be some sort of a slippery slope towards a more anti-realist empirical adequacy type of view? And finally, I'll make a third comment about the scope of realism and about science. So realism and anti-realism, as Elliott said, are very often defended as monistic theses that apply to science as a whole. But there are some selective realists that say that truth only concerns some aspects of scientific theories. So for some, it's those aspects that are needed to explain success, as in explanationism. For others, it is those aspects that lend themselves to causal manipulation, as in entity realism. Still, for some others, what should matter are those aspects that concern structures or relations, and this is what we have in structural realism. But in any case, independently whether these selective theses are defendable, they all make claims about science as a whole, right? But is science really that homogeneous, given its diversity of fields and its diversity of research programs? So what constitutes scientific representations in particular may very well vary across science. So we may have, we may talk about theories in particle physics, but models in behavioral ecology. Also, which aspects of scientific representations to favor may also vary across science. So we may favor theoretical working parts in some areas of science, entities, causal manipulation in others, still structures in other parts of science. And maybe also what constitutes acceptance or theory acceptance may very well vary across science. So maybe it can be empirical adequacy as minimal requirement in some areas of science. It can be predictive accuracy in others. All the other usual criteria for theory evaluation, including simplicity, for instance, or corroboration. Given all these inhomogeneities, I mean, it seems that all this definitely go in the direction of the type of pluralism hinted at by Elliott Sober. So the questions that we have now is, how could we flesh out such a pluralist position? Are the dimensions that I mentioned just earlier, types of descriptions, parts of descriptions, criteria for acceptance, are they the most central ones? Are there other dimensions that would matter? How should we also settle on the matter here? And with such a pluralist view, then, how should we think about the realism, anti-realism positions? Are we heading towards a pluralist view which concerns some sort of a division of the territory of science into some realist and anti-realist domains, depending on some of the dimensions in different fields of science? Or are we going to maybe some portions of science in which there is some sort of a middle ground for realists and anti-realists to meet? Or is this pluralism leading to an alternative position that would no longer be compatible neither with strict realism nor with strict anti-realism? So with that, I'll stop. I'll thank again Elliott for his very inspiring lecture, and I'll let him say a few words and then we'll take questions. Thank you again.
Thanks, Christophe. There's a lot to talk about here. And I took notes as you were presenting your ideas. So you started by by describing this conflict that arises when we think that the science we have now is very well supported. It's convincing in numerous ways. We think we know the world well, and here's the story we tell. And at the same time, we reflect on ourselves and realize that the concepts we have are historically contingent. People at different times and places had different concepts, different theories. Our descendants will have ideas and theories different from our own. So it seems naive and hubristic to think that the theories we now think are so great in 2021 are true. So there seems there's a conflict here. I certainly feel that conflict that you described. I agree that it's a real thing. The kind of realism that I sympathize with does not, the preferred mode of expression is, this theory is our current best guess as to what the truth is. It's better than the alternatives. I think it is hubristic to go beyond that and say it's not only our best guess as of 2021, but it's true in the sense that in future generations, no better theory will ever come along. So I'm a very modest realist in that sense. There are 2 points here. One of them, I want to recognize the historical contingency. I still want to use the word true, so that's a realist thing. Here's the thing. I want to think of that kind of realism as a contrastive thesis. I'm not saying this theory is true. I'm saying this theory is a better picture about what's true than this other theory that we've considered. Given the alternatives, this is what's reasonable to believe. So it's contingent on this sort of contrast between one theory and its alternatives. I'll move down my list of notes that I took. Von Frossen used the word acceptance to mean something from belief. In the language I speak, they mean the same damn thing. So it always irritated me that he did this, but in a way it doesn't matter, because let's just stipulate that he gets to define acceptance so that it means something different. It's an abuse of English, but so what? So what he means is when you accept a theory, you think that it's empirically adequate. And moreover, you take on, he thinks, some sort of commitment to work with the theory or say nice things about it. I'm not sure what else. But if you just restrict it, acceptance to mean you think the theory is empirically adequate, it's clearly different from believing the theory, which for me means nothing other than believing that the theory is true. I guess that's just a complaint about terminology, not a substantive thing. Dinosaurs are observable is something that von Frossen says. I was just using his way of characterizing observable and unobservable. And it's important to notice that he characterizes that distinction as a distinction between kinds of entities. And in this respect, he was dramatically departing from an older formulation in which statements were either observation statements or theoretical statements. Your computer is not a statement. Dinosaurs are not a statement, but but it's objects that are either observable or unobservable for him. I think there's room to talk about what observation statements are. I didn't get into that in this talk. I think we need that concept. It's not sufficient to talk about entities being observable. You are entirely correct, Christophe, in what you say von Frossen's preferred formulation of empiricism is. It doesn't say we ought not to believe that a theory is true. He says that belief that it's true is supererogatory. You're permitted to say that, but you're not obliged to say it. And okay, that's fine. I think all of the arguments that I made about empiricism apply anyhow to that. If that's a more careful way of formulating von Frossen's. So go back to my dinosaurs versus electrons example, in terms of the law of likelihood. An empiricist would want to say that, well, let me erase that. I have a problem with the idea of dichotomous belief also, that we either believe a proposition or we do not. What I think is more sensitive is the nuance that comes in when you think about degrees of confidence or degrees of belief. So I don't think realism or empiricism should be formulated in terms of the concept of dichotomous belief. We could talk about our degrees of belief in statements about about dinosaurs, and the degrees of belief we have or ought to have in statements about dinosaurs and electrons being the two examples. That's fine. And his idea about it's not being an obligation. Well, if the law of likelihood tells us, applied to two statements about electrons, that one of them has a higher likelihood than the other, and if von Frossen or some other empiricist wants to talk about degrees of belief and has prior probabilities, which I don't like either, they will then want to talk about degrees of belief in statements about dinosaurs and also about degrees of belief in statements about electrons. And to me, these two problems are entirely on a par with each other. And again, so what I'm trying to say, not very lucidly, I'm afraid, is yes, let's examine von Frossen's position that empiricism does not say you ought not to believe statements about electrons. He's saying you are not obliged to do it. Second step, belief is a coarse-grained concept. Let's substitute belief, degrees of belief. And when you do that, I don't think there's any room for dinosaurs being observable and electrons being unobservable, making any real difference in how that plays out. So I think my objections still apply, but your point about being sensitive to how he really wants empiricism to be understood is well taken. On truth and approximate truth, I think it's generally granted that Popper's way of defining verisimilitude didn't work. There might be better ways of doing it. You mentioned some of them. I don't have any comment on them. One thing that I would urge be put on the table as an option is this distance measure that's used in statistics called KL distance, Kullback-Leibler distance. It is the distance to the truth that one probability distribution has to another. And it's an interesting way of thinking about approximate truth for probability distributions. It doesn't apply to all statements. It's got to be a mathematical statement where the target is a mathematical statement, and that the truth is a mathematical statement. And you want to talk about different other models approximating it better or worse. And the reason I know about KL distance is that it's a way of describing what AIC is about. It's a way of estimating KL distance to the truth. So I'm very much in favor of the idea of trying to develop the idea of approximate truth. I don't think we'll ever get anywhere on non-mathematical statements like light is a particle versus light is a wave. But with respect to mathematical science, I think there's room for progress to be made there. You mentioned at the end, you mentioned the idea that you might want to be a realist about some parts of the theory, but not others, rather than being a holist about it's the whole theory that I'm a realist about. I totally agree with that. And one of the things I really dislike about Quine's epistemology is that it's a holistic epistemology. You embrace the whole theory and all its consequences, and they're all on the same footing. I think there's an important distinction to be made between some elements of a theory that are well supported by evidence and other elements that are merely conventional. So this is a kind of Carnapian idea that I think is viable. And it's part of being an anti-holist. You have to pull the theory apart and look at its different constituents, and they have different justifications. Some of them have no justification at all. We shouldn't just talk about the whole theory as if it was an undifferentiated object. So I agree with you there. So thank you for those comments.
Thank you very much. Thank you very much, Elliott. We have quite a few questions in the chat, so we'll take them one by one, and we have a bit of time. So we have a question first by Yves Gingras. Can you please unmute yourself and switch on the video? Oh, Yves, okay. You cannot unmute yourself.
Okay,
you don't have any voice, now it works, right?
Okay, it works. Thank you very much. Okay, I have a brief comment on Van Fraassen and then a question about the pluralism. Many years ago, when Bass came to give the Leblanc lectures, we had this discussion about, we're not obligated. I think it's just wrong. I gave the very simple example. I told him, I said, it's linked with Brownian motion. The difference between classical thermodynamics, which is an homogeneous theory with no entity, Einstein's statistical mechanics found a difference because up to Einstein Brownian motion, we thought that we could not distinguish statistical thermodynamics and classical thermodynamics. And Duhem always worked on classical thermodynamics, and the revolution was, so I said, now, since there is an empirical difference between statistical mechanics and classical thermodynamics, and that this difference hinges on the existence of discrete atoms, I said, I cannot understand. You can tell me that now you will take statistical mechanics without the atoms. It's just illogical. So I think it's logically false to say that in some cases, you're not committed. In some cases, of course, we don't know, for example, light and waves and things complicated, but he could not answer me because I think it's just plainly wrong. And now I come to my question, and you could answer on both aspects if you wish, but I was surprised as I see a kind of contradiction between the beginning of your talk when you say that we're talking about normative. We're not asking if scientists want to be realists or if they want an adequate theory. You said we want to have a normative view of what science should be. And this I understand plainly. But then at the end, you say, well, we can be pluralist. In some cases, we're happy with descriptive that it works, which is the case in many phenomenological science. But in other, we want to be true. But if that's the case, then we come to just the sociology of it, that some scientists are realists, some are anti-realists, where at the beginning you were saying, no, no, I'm not interested in that. I'm interested in what science should be. So did I miss something here?
No, I think you caught me in a contradiction, perhaps. I think, so let me try to say something normative about what seemed like merely a descriptive thing that I said at the end, which I guess it was descriptive. I think it's okay when scientists try to construct models and judge them on the basis of their expected predictive accuracy. This is what meteorology is about, all these models about climate change. They're all filled with idealizations. And to insist that a theory has to be true, literally true in all the different details, this would just paralyze that and other sciences. So I think there's plenty of room for this. I mean, in the fullness of time, maybe we'll have a theory that's true in all respects. But for scientists on the ground now, I think there's lots of room for thinking about which models are better predictors than others. I think it's a good project. So that's my normative thing. So maybe that's a way of restoring consistency. I was very entertained by your description of your conversation with von Frossen. I completely agree. I mean, I would offer a slightly different formulation, but instead of saying you are obliged to believe in the existence of atoms because look at this, which I do believe, my preferred epistemology is you have fabulously strong evidence favoring the existence of atoms over the non-existence of atoms. Come on. And it's just as strong, if not stronger, than lots of evidence we have for the existence of dinosaurs. So there crumbles the distinction between observable and unobservable. I think that's it's epistemologically silly, that distinction. It's a shame, really. I mean, so I really don't, I'm trying to be a pluralist about realist and instrumentalism. I don't have any time for that kind of empiricism. Come on.
Makes sense.
There's lots we don't know about dinosaurs, tons we know about atoms, of course.
Fabrice Valcourt has a question also. Oops, we're here for the microphone.
Yes, hello. Okay, fine. Yeah, well, thanks again for your talk today, Mr. Sauber. I told you yesterday, very naive questions that I asked. Today is no exception. So I was curious, we're talking about the value of the concept regarding the truth in the theory, right? And I guess that's the whole point of it between realism and anti-realism. I was wondering what place could we give to the usefulness of a concept in a theory, because we don't just comment ontologically to the concept of atoms solely on the basis of some observations that we make. It's also that atoms have a usefulness in explaining other concepts within the theory. So I was just curious, where would you place this concept of usefulness?
Well, okay, one kind of usefulness is utility in constructing explanations. I was sort of expecting you might be talking about a different kind of usefulness, namely, it leads us to construct instrumentation that allows us to manipulate the world in the ways we want. That would be a different kind of usefulness. But let's stick to the example you gave of the usefulness in constructing explanations. One aspect of that question is when I construct an explanation using, say, the concept of atoms, how am I supposed to evaluate whether it's a good explanation or not? I mean, we can use all sorts of concepts to construct explanations that'll be horrible. So we need some epistemology to sort of tell us, okay, you've used this concept, let's see how good your explanation is. I think one of the key tools in that department is the law of likelihood. So you want to see how well does this theory probabilify the observations you made? How well does it fit the observations? That's one way to describe whether it's a good explanation. I mean, there's a broader question here, which is, I mentioned very briefly this idea that philosophers like called inference to the best explanation. And it's often presented as an epistemology that's distinct from Bayesianism or anything probabilistic. And whether that works or not, of course, depends on how good explanation is characterized, and some arguments to show that explanations that have this, and this characteristic are better in some way that should make us believe them more or use them more or something like that. But I certainly think usefulness in explanation and in other respects can be often linked with evidence for the theories actually being true.
Thank you. We have four more questions here. So Nicola Bertoldi, if you can unmute and switch on your microphone. Okay, it works.
So thank you, Professor Sober, for your talk. Actually, since numerous debates about realism and anti-realism in the sciences hinge on the particular mathematical formalism that are used in those sciences, and I'm thinking notably of quantum mechanics. I was wondering what's the place, what would be the place of mathematics, in particular applied mathematics, in a version of scientific realism that you would be willing to defend?
Certainly the mathematics that's used in a science is, I mean, important to understand if there are alternative mathematical formulations. I mean, understanding whether they're equivalent or not, how they differ if they differ. That's all very important. The mathematical relationship between one scientific theory and another. Is the second a special case of the first? Is it incompatible? These are super important just for understanding what the theory is actually doing. So I agree with that. I personally think that realism as an issue and its alternatives like empiricism and instrumentalism apply both to mathematical theories and to non-mathematical theories. So there are, of course, going to be mathematical questions that are specific to mathematical theories, of course, but whether they lead to special problems of realism or special problems about empiricism, I'm not sure whether that's true. One way it would come up is if you have two mathematical formulations of a theory and you think that they are empirically equivalent, how are you supposed to tell which of them is true or not? Or maybe you'll think that that's all there is to a theory is being true, that it's the two theories that are empirically equivalent are either both true or neither is. So that's, I guess, here's a place in which questions about realism enter into mathematized science.
Okay. I don't know if I'm going to pronounce the name correctly. Pavlo Jovanovic.
Hi.
Okay, good.
So first of all, thank you, Mr. Sober, for the talks and for all your work. Unfortunately, Mr. Yves Gingras basically already anticipated exactly what I was going to ask, which was about how does pluralism fits into, I guess, your overall view of the ends of philosophy of science and of the realism debate. But since the question was already asked, I guess I'm gonna let others get a chance to have the time.
Okay, unless you want to add something, Elliott. Otherwise, we'll
no, let's go ahead.
Michel Martin has a question. Do you want to unmute?
Hi, thank you for your talk. I have a question about, I'm just wondering if it would be useful to, sorry, my computer is giving me issues. If it would be useful to think about the distinction between realism and instrumentalism and the aims of science that they cover, so to speak, along an axis of fundamental versus applied research. So in fundamental research, you would be more concerned with truth approximation, whereas in applied research, you would be quite satisfied with instrumental results. I'm wondering if this applied versus instrumental distinction would be useful.
Yes, I think that might be a good pattern. I mean, there might be some exceptions to the pattern, but it's still a real pattern that in applied sciences often approximations, idealizations are tolerable because the goals are more practical. So yeah, I think that's a good idea. I agree.
Here, if I may, I'll take some chair prerogatives. And it's a follow-up question that I would have is, but then how should we think about, models in behavioral ecology that I quoted? It's far from being a fundamental science. I mean, we're not talking about atoms and quarks and fundamental particles. It can be extremely applied somehow if we want to know how to preserve specific ecosystems or a particular species. And on the other hand, we definitely know that the models are extremely poor approximations. So I'm not sure, it has to be more complex than that. How are we going to divide what we think would be, areas where we think realism or instrumentalism would better fit. I'm not sure it is so straightforward. So I don't know if you want to comment on that.
I want to think about this as a contrastive problem where it's not, we don't look at a single model or a single theory, but rather a collection of competing models. And the question isn't which is true or which is empirically adequate, but which is better in some relevant sense. It could have a higher likelihood or a higher AIC score or something like that. And the challenge for some of the work I think you're thinking about here is to make a theory more realistic and have it remain a tractable theory that actually makes predictions rather than just being hopeless in terms of applicability to real world systems. So that's a kind of maybe a distant goal.
Makes sense, definitely. Andrew Lug has a question.
Yes. Can you hear me?
Yes, everything's working.
Okay, I've got it. All right, good afternoon. I wanted to ask you, Professor Sober, about Quine. You did mention one point there where you disagreed with him, but when you were going through your talk, I was thinking a bit about him because, as you know, he claims to be a robust realist and an empiricist. Empiricism for him being whatever comes in, the impingements, the meager input. And also he has the view that, that about epistemological significance, it seems not to be a major thing for him because at sometimes he thinks it is of major significance, but towards the end of his life, he was in the 90s anyway, he was suggesting that it wasn't of a major significance. So what I was wondering, if you could say a few words, whether it's just a difference of language here, or whether there's some real substantive differences between his line of thought and the line of thought of your paper.
Okay, I have a thought about one part of your question, but I'm going to have to ask you a question about the second part to get clearer on what the question is. So you mentioned that Quine described himself as both a realist and an empiricist. He was a realist. He thought electrons exist. He thinks numbers exist, sets exist, because our best theories about the world postulate the existence of these things. I mean, that's where he's coming from. And he's an empiricist in the sense that he thinks that observational input is a serious, fundamental source of information for evaluating theories. So he's a realist and an empiricist, and that as he was using those terms, and of course that's jarring given the way I was using the terms today, where realism and empiricism are incompatible with each other. And I think what's going on here is he was using the term empiricism in a very familiar, everyday way, not in this sort of specialist meaning that it has come to have in philosophy of science about empirical adequacy, not truth being the goal and all that stuff. So that makes things fall into place, I think. Okay, I mean, so there's no disagreement, I think, between Quine's being a realist and an empiricist and what I was saying. I mean, the reasons for being a realist are a bit different, though. The thing that I didn't understand in your question was when you talked about how in the 1990s, he said that something was not significant, or he used to think it was significant, then he abandoned that. What is the thing you were referring to there?
Sorry,
I missed.
yeah. The empiricism, let me just say one little thing about the empiricism. The empiricism for him is sense impressions is all we have to go on. And that's compatible with what you were saying and what the robust realism, which he said he's a realist in the only sense you could be a realist. No, I was thinking of the distinction between observation statements and theoretical statements.
Right.
And in word and object, for example, that's a very sharp distinction. And well, actually I'm sorry, that's not true, but there was around that time a sharp distinction. And then in a paper called Progress on Two Fronts, he backs off completely on that and says that, that he says he's fine with Kuhn and Feyerabend and all these people. I'm not so sure how much he knows about them, but he mentions them. So he's quite happy with the theory-ladenness of observation. He uses that sort of language. But what interests me is that and what I guess I was asking you for some help was whether, for him, that seems to be a minor issue. It's one he has to get clear on, given his views.
Yes.
He's working out this view of our knowledge, but it's only something he has to work out. It's not something that's going to bear on his views about robust realism on the one hand and the empiricism, which, as you mentioned it. So that's what
good, I understand now. So here's my picture of Quine, and it's possible, certainly possible, maybe probable, that it's a snapshot of Quine at a certain point in his career, and this is not something he consistently maintained. And I'm thinking of the Web of Belief here as a kind of canonical example of his publications, where you have this giant theory about the world, and of course you're going to modify it in the light of new experiences that you have, sensory inputs, but that's not the only thing you're worried about. Compatibility with observations is just one consideration. You have simplicity and unification, explanatory power. So it's a multi-dimensional epistemology for revising the web of belief. And it's connected, and part of that holistic picture is connected to what you were describing about the difference between observation statements and theoretical statements. I mean, in Two Dogmas, he has the idea that some of our beliefs are more central to our system of beliefs, others are more peripheral. And that's an important consideration in deciding what to revise. And that peripheral versus central thing, I think, corresponds somewhat to, you know, what we might call observation statements and highly theoretical statements. So they're both, there is a distinction there. It's a matter of degree distinction for him between what's central and what's peripheral. It matters, along with 20 other things matter in terms of the sort of pragmatism of how you should go about revising your beliefs.
Yeah, I think that seems to me right. And yeah, but prediction in the end is the major thing for him. The other ones are for getting the theories in order to check them. And so it does come down to prediction being very important. And that would be, I think I'm right in thinking that that would dovetail nicely with some of the things you were saying, that because you're very interested in prediction.
Right. I mean, one more comment about Quine. I mean, I think he was focusing on deductive relationships very often. So, and he regarded weaker relations, probabilistic relations between statements, as somehow important but a mystery. And there's this wonderful passage in I think it's the Two Dogmas, where he says, aside from simple-minded examples about urns, I was talking about urns today, we don't have the slightest idea how to think about evidence in a probabilistic way. So he knew it had to be important, but he didn't really have a way of working with. What he felt clearer about was deductive relations. And of course, if that's what you're thinking about, if a theory entails a statement that you observe is false, I mean, modus tollens, you know the theory is false. So in that sense, observations are fundamental. It's a sort of rock that you can use to refute a theory. What he didn't get into is when you have different theories that lend different probabilities to observations, like how do you handle that? And it's just not part of his framework to really delve into that.
Yeah, that seems right. He has virtually nothing to say on probability, right? Nothing along the lines you were suggesting.
I've been a poor timekeeper. It's
thank you.
I see the clock is ticking, but I guess those who are still with us are still interested in the debate. I don't know if we have just a little bit more time. There is Yves Gingras has another question. Maybe that could be the last question for tonight. Are you okay with this, Elliott?
Sure.
So Yves, do you want to ask another question?
Okay, now I got it. Okay, thank you. I would like to come back. I will use the fact that at the beginning you mentioned the Galileo case, and I have something to submit to you about empiricism, because the Bellarmine argument is what I call a Catholic epistemology. For Bellarmine, the reason hypotheses are good is that only God knows absolute reality, because God could do the world the way he wants, and our feeble mind does not make us possible to know the truth about the ontology of the world. And to that, Galileo had an answer at the very end in 1632 of the book, saying that, yes, it is true, but God gave us reason. And because he gave us a reason from God, I think, Galileo, that we can get at truth. Now, here it comes. Pierre Duhem was also insisting, and he's a good Catholic. Pierre Duhem was a good Catholic, and he was on the side of Bellarmine, because we cannot have access to reality because it's God knowledge. Then we come to Bas Frassen in his empirical stance, who is also a believer. So my question is, do you think, as I do, that there is, in fact, up to now, an interesting correlation between being an empiricist and insisting that the veil of reality is there because the real reality is only that of God. So we can be very good at making prediction, having good theories, but we cannot say we have the knowledge that there is X in the world because it's only absolute knowledge of God. Because it's surprising that those who are empiricists are very often, in fact, believer.
Well, that's a tantalizing hypothesis. And, you know, examples like that suggest that there might be a connection, not, I would say not a logical connection, but a psychological connection. That's what you're talking about. I mean, I would add to that another set of individuals. Marxists tend to be realists. So maybe that could be part of the psychological hypothesis you're thinking about here.
Because in the case of Van Frassen, as you seem to understand also clearly, some of his argument against saying that the entity exists are just non-logical.
That's how I feel. Yeah.
I
think Bas.
On the
I don't know. I have never had the chance to psychoanalyze Bas van Frassen, but I think he's made a bunch of arguments. I think Scientific Image is a beautiful book full of interesting things. And the psychology, maybe there was some sort of psychological motivation there from his theism to want to develop this. But to me, the arguments stand on their own and they're interesting.
Yes, of course.
And I think it's possible that Bas van Frassen himself doesn't know how his own mind works.
Yes.
I certainly believe that I don't know how my mind works. Okay. So I was just teaching Richard Lewontin's papers on the unreality of human races. He was a Marxist. He is a Marxist. And he obviously had a political agenda for attacking the idea of race. But he had some great arguments and interesting science was developed. I mean, I don't really know the motivation very clearly in his case either.
Thank you.
Wonderful. This is a time then when normally we would all go and have a beer or something and continue the discussions informally. Unfortunately, we can't, but we can definitely thank again Elliott for his very inspiring lecture and all the discussion that we had, and can also say that we should meet tomorrow again for the third lecture. I guess you can see here the poster of the lecture. So we'll convene at the same time, 3:30 Montreal time, same place, same Zoom place. We'll have a lecture on values in science, and Matt Barker will be the commentator. So thank you again, Elliott. Thank you everyone for joining us, and wish you a good afternoon or good evening, and see you tomorrow, fortunately.
Okay.
Thank you.
Bye-bye, everyone.
Bye-bye.